Hello everyone, I welcome you all to Physics Wala, and in this session we are going to discuss our next chapter of physical chemistry, which is atomic structure, or I can say structure of atom. So basically in this particular session we are going to start with the basics of atomic structure or structure of atom. We'll get the idea how the discovery of fundamental particles actually occurred, and we'll discuss some more portion. First of all, I'm going to discuss about the basics of this particular chapter, how you can decide the flow of this particular chapter, because there are enormous things which are related to atomic structure. And after completing the first chapter, which is your some basic concepts of chemistry, or I can say mole concepts, now it's time to discuss about the fundamental particles, because that first chapter was discussing about a very interesting thing, that is the quantification related to total number of atoms, or I can say total number of molecules, or I can say if I talk about elements, compounds, how you can quantify that particular part, how you can calculate the mass of that particular atom. But the next question which arises to everyone's mind is like, if I am talking about the fundamental particles, if I am talking about some smallest particles which are basically atoms and molecules, how the discovery of these elements as well as molecules occurred, how you can actually talk about the basic idea of that particular part, which is atoms. So this chapter is actually dedicated to the entire portion related to atoms. So the portion which we are going to discuss in this particular session is very interesting. First part, we are going to discuss about the introduction part of this chapter, which is a structure of atom. In that case, we are going to discuss about the fundamental particles as well as their discovery. Then we are going to discuss about the important terms which are associated with that particular atom. Then we are going to proceed on the next part, which is electromagnetic radiation, and we will try to discuss black body radiation as well as photoelectric effect. Okay, now if I talk about the basic part, whenever we talks about the structure of atom, which basically is dedicated to the entire part of atom, because for the calculation part, or I can say the introduction part, the main important thing is we need to know about the basics of atom. What are the main constituents of atom, how you can say one atom is stable, one atom is not stable, what are the factors which are responsible for the stability of that particular atom, how you can define the arrangement of fundamental particles inside the atom. So in that case, the first portion is basically the timeline, which is very important. Now I can say like this particular part, this session is going to be slightly theoretical, although this chapter belongs to physical chemistry. So definitely we are going to discuss about the calculation part of various factors, either the radii of that particular atom, or I can say the size of the nucleus. We can talk about the position of electrons, protons as well as neutrons. But in that case, first of all, we need to understand some theoretical portion also. So this particular lecture 1 is going to be slightly theoretical, but trust me, this is going to be very interesting. Now one question I want to clarify, like most of the students are concerned about the level of these lectures. Most of them were saying like, are they required for NEET UG level, are they required for JEE mains level, or we are going to discuss some other portion also. So first of all, whenever you are preparing for any competitive exam, either it's your JEE mains or advanced, or it's your NEET examination, the first thing is you need to clarify all your basics. So first we'll try to cover all the basics which are relevant to your particular examination. Then we are going to discuss all the questions from the basic part to a maximum possible extent, so that the entire part is going to be clarified to everyone. Okay, I hope I gave you the actual answer, which was actually very much required for all of you guys. Okay, so let's start. If I talk about the basics, or I can say the introduction part of this particular chapter, introduction is very interesting. I can suggest you to actually read first 1 or 2 pages of your NCERT book, so that you can get the idea about the basic discovery of atom. But there is one important theory which talks about the discovery of that particular atom, which consists of all the laws of chemical combination, and you know the answer, that we are talking about the Dalton's atomic theory. So the entire part related to the atom, or I can say the discovery of atom, starts with the basic analysis of atom, which is basically your Dalton's atomic theory. Now if I talk about the flow of this entire chapter, I can say we can start with the basic analysis of atom. And this basic analysis of atom is basically, there are certain limitations also, but we can talk about this part, atom, with the help of Dalton's atomic theory. Now, this Dalton's atomic theory may not talks about the actual structural analysis of the atom, but it also talks about the term which is atom. Now, after this particular part, you can move to the next portion, which is discovery of fundamental particles. Now, in this particular case, if I talk about the discovery of fundamental particles, although there are different type of subatomic particles, but mainly we are concerned about the electrons, protons, as well as neutrons. I hope this part is clear. Now, covering this entire part, there is a concept which is in accordance with the classical physics. So, in that case, I can say that the classical physics talks about the nature of a wave. So, generally, this pattern, or I can say the behavior of these fundamental particles are actually somewhat related to the nature of waves. After that, we are going to relate the next part also, the particle nature. But first of all, to understand the basic idea of these electron, protons, as well as neutrons, their behavior, we need to understand the nature of waves, or I can say nature of electromagnetic radiations. Okay, definitely we are going to talk about the electromagnetic radiations, as well as in that case, to understand the basic part, we need to understand the characteristics of waves, so that we can entirely talk about the concepts which are in accordance to the classical physics, because this chapter is actually in physics as well as in chemistry also, and most of the portions are actually very similar, because the structure of atom is going to remain constant. The nature of electrons, protons and neutrons is going to remain as it is. So, the first part in this case is basic idea about the atom, then the discovery of fundamental particles, then the basic characteristics related to electromagnetic radiations, then we will try to operate the part, we will try to explain the wave nature of these fundamental particles. We can say, we can talk about the wave nature of fundamental particles. Okay, after this particular part, when this wave nature was actually clarified, some scientists did certain experiments to explain the particle nature of these fundamental particles. So, the next part is basically to prove particle nature of fundamental particles. Okay, and next part, after covering the entire portion related to wave nature as well as related to your particle nature, then we can talk about the basic structure of atom with the help of different parts, which are atomic models. So, there are different atomic models. You can say Thomson model of atom, Rutherford's experiment, as well as Rutherford's nuclear model. Then you can talk about the Bohr's atomic model. But there were some discrepancies in that last model, which was Bohr atomic model. So, we will try to figure out, or we will try to combine both the things like wave nature as well as particle nature, which is the dual nature of matter. Because in chemistry we are discussing about the nature of matter. So, let's try to combine these two things. First one is the dual nature of matter, which corresponds to particle as well as wave nature. Now, after covering the entire part, you know, we have covered all the basics. Now, it's time to discuss the most advanced model, which is actually known as quantum mechanical model. Now, remember, this entire part is the most interesting portion as well as the most important portion related to the structure of atom, because this is the only model which talks about the actual analysis of atom, and in that case you will get to know about the idea of shells, you will get the idea about the subshells, as well as the idea about orbitals. Okay, and after covering this entire part, we will left with the application part. I hope the entire flow is clear to everyone. Although like there are multiple things in each and every concept here, we have a certain portion related to discovery of fundamental particles, which corresponds to your cathode ray experiment, anode ray experiment, as well as the discovery of neutrons from the radioactive type decay. In that case of this electromagnetic radiation, we have electromagnetic spectrum also. In case of a wave nature, we have diffraction pattern as well as interference. In that case of particle nature, you have black body radiation as well as your photoelectric effect. If I talk about the atomic models, I already gave you the idea. We have three main models as well as the most advanced version, which is the quantum mechanical model. Then you have the de Broglie analysis or de Broglie hypothesis, which corresponds to dual nature of matter, which is the de Broglie wavelength. In the same way, if I talk about the quantum mechanical model, before that, like there are certain experiments also. First one in that case is Heisenberg's uncertainty. In that case also, if I talk about the particle nature and wave nature, in between that we have one more theory, which is Planck's quantum theory. So you know, like this chapter consists of many theoretical portions as well as many numerical portions, and trust me, this is going to be very, very interesting. So this is the first session. Let me clarify one thing. If somebody tells you like this is a very basic portion, this is not up to JEE level or it is not up to NEET level, so every first lecture of any chapter is going to be very, very basic one, which is the introduction part of that particular chapter. So like I cannot say like most of the questions are coming from this particular portion, this lecture one, but yeah, this is actually required to understand the rest of the portion, which is actually very relevant to your examination. Okay, I hope up to that part everything is clear to everyone. Okay, so let's start with the first thing, which is the Dalton's atomic theory. And if I talk about the introduction part, we need to understand like in what dimension we are discussing the atom. So if I talk about the macroscopic scale, where you can easily see any type of a matter which can be easily seen by the naked eye. So this particular size of a particular matter is going to be very, very large, and you can easily see this particular part. And matter, you already know the basic idea of matter. So anything which has mass, occupies space and can be felt by our senses is basically your matter. So the study of matter is nothing but chemistry. And if I'm moving from macroscopic scale to microscopic scale, now in this case you can see the dimensions are going to change drastically. It is basically equals to 10 raised to the power minus 10 meter, which is 1 angstrom approximately. I'm not saying that every atom is going to be 1 angstrom only, but it is in the range of angstrom, so which is very, very, very small. You cannot see this particular part with the naked eye, but we know about this particular part, so definitely we need certain experiments to prove that the dimension of atom is going to be very, very small. So the first part is actually your Dalton's atomic theory, which actually talks about the part atom only, and it is basically the combination of laws of chemical combination, which consists of your law of conservation of mass, law of definite proportion, law of multiple proportions, all these things. Now, talking about the first part related to the very first postulate of Dalton's atomic theory, it simply says that every type of matter consists of very small particles, or I can say very small indivisible as well as indestructible particles, which is actually known as atom. So the first part is very easy. Every type of matter consists of very small particles, which are known as atoms. Now it simply says that atoms are indivisible as well as atoms are indestructible. They are indivisible as well as indestructible, because up to Dalton's atomic theory, no one actually clearly said about the idea of atom. They didn't know about the fundamental particles which are present inside the atom. They didn't know about the nature that atom can be easily divided or it can be destruct into some another type of form. Now in this particular case, the first postulate is very easy. Now the second postulate in that case, if I'm comparing every type of matter or every type of element, every element consists of a same type of atoms. So the second part is every element contains same type of atoms, and two different elements have different type of atoms. And remember one thing, if I'm talking about the same type of atoms, in that case always remember these same type of atoms have same size as well as properties. I hope this entire part is clear. And if you are comparing two different elements, definitely their atoms are going to be different. You can compare the oxygen element as well as nitrogen element. In that case, the atoms of oxygen are of oxygen only, and atoms of nitrogen are of nitrogen only, and these two atoms are entirely different. So these are the main postulates, first 2 or 3 postulates of your Dalton's atomic theory. I hope up to that part everything is clear to everyone. Just look at it. We will discuss the next portion. Okay. 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 Now the basic thing is, if I am talking about the next postulate, sorry, I guess the mic was not on. Okay. So basically the idea is very easy. The next postulate is again very interesting. It simply says, according to the law of definite proportion, whatever the source of a compound may be, their elements are always going to combine in a specific ratio of their mass to form a particular compound. So this postulate simply says, whenever a compound is going to be formed, the two elements or the atoms of two elements are always going to combine in a specific ratio. So always remember, in the formation of compound, atoms of different elements combine in a specific ratio, which is basically your law of definite proportion or constant composition. Now it may be possible that when we are combining two elements to form more than two compounds, again in that case always remember the elements are always going to combine in a specific ratio, and it's also possible that with from two elements you can form more than two type of compounds. Okay, so in that case it simply says that atom is going to participate in the reaction to form a particular compound. I hope these postulates are clear to everyone. Now the next thing in that case, if we know about the entire portion about this particular part, we can say that in every type of reaction, atom is the only thing which is going to participate in any type of reaction. So that is next postulate related to Dalton's atomic theory. So we can say from this particular part, in every reaction, atoms are going to participate in a specific manner. Okay, so basically atoms are the fundamental particles which are going to combine together or which are going to participate in the reaction to form different type of products in the reaction. I hope up to that part everything is clear to everyone. But again, we know like there are certain limitations also. If I talk about the limitation part, we can say that atoms are divisible. Atoms are divisible because research as well as experimentation shows that we have some fundamental particles. We have some fundamental particles. So this fundamental particles discovery actually disproves that particular point of Dalton's atomic theory, that atom is actually indivisible in nature. You can actually find out certain fundamental particles. Next part is atoms are actually destructible in nature. It means like which type of theory or which type of experimentation proved that particular part? The discovery of radioactive elements. So you know like everything is correlated in this particular chapter. So if you know the basic idea, if you know the timelines, you will get to know about the each and every part. Because like in my opinion, most of the students are not concerned about anything. They find everything as a new concept. Like they generally say to me, sir, we were discussing about the fundamental particles, electrons, protons and neutrons. Why we switch to the wave nature? Why we are discussing about the Heisenberg uncertainty principle? Why we are talking about the photoelectric effect? Like there is no correlation. So you have to find out the correlation. That's why I am giving you the basic idea about the timelines. If you know the discovery timelines, then you will get to know like every concept of this atomic structure. Like to know about the actual structure of atom, you need to understand the previous concept which is actually associated with the discovery of that particular atom. Atoms, like I can say, like you have a one book in 11th class, part 1, and you have two books, second book in 11th also. So we have part 1 book and we have part 2 book. So this is the basic introduction about the books only. But in books you can find, in first case you can find 7 chapters, in second book again you can find 6 chapters. So this is more in-depth analysis. Now in these two books, in first book you can find only the chapters of physical as well as inorganic chemistry. In second book you can find mainly the chapters of inorganic as well as organic chemistry. So this is again in-depth about that particular book. In first book you can find first 2 chapters of physical chemistry, then next 2 chapters of inorganic chemistry, again more in-depth analysis. So to know about the entire part of your 11th book also, you need to understand that you have 2 books initially. Then in 2 books, how many chapters are there? In that chapters, what is the differentiation of physical, organic and inorganic chemistry, and what is the basic concepts which are present in first book as well as second book? What is the weightage of first book and second book in your examination? So to know about that particular part, because we are mainly concerned about the portion, like what is the percentage weightage of first book as well as the percentage weightage of second book. So to know better about the percentage weightage, first of all we need to know that we have 2 books. Okay, so that's why to know about the actual structure of atom, we need to understand about the atom only. Okay, so these 2 parts are there as a limitation. In the same way, if I talk about the reaction analysis part, that in every reaction atoms are going to combine. So what is the driving force? What is the driving force for combination? So I'm saying that atoms are going to combine together to form different type of molecules. They can be like one type of molecule can be possible, more than one type of molecules can be possible. So what is the driving force, like how they are actually combining together to form a particular compound? So that part was missing in the Dalton's atomic theory. Like there are different portions related to the entire part. Dalton's atomic theory was completely unable to talk about the particle as well as wave nature. Okay, it was unable to find out any fundamental particles. So these are certain limitations of Dalton's atomic theory. But this theory gave us the idea that we have something, we have our smallest particle, which is basically atom. It may or may not be stable. So again, the next question is about the stability. So it was unable to talk about the stability of an atom. Now you see, like, limitations are very strong points. So that's why we have to opt out, or we have to do certain other experiments to prove that other than atom, we have other fundamental particles which are present inside the atom, to know about the actual reaction part. Because in chemistry, our main focus is actually what type of reaction is happening, how a reaction is happening, how the atoms are going to rearrange themselves. So these three questions, I can say, they are the most important one to answer. So that's why scientists worked on the discovery of all the fundamental particles. Now I can say the discovery of fundamental particles was very random, because the experiment which proves about the discovery of the first fundamental particle, which is electron, was entirely a different set of experiment. So if I talk about the first part, which is the discovery of electrons, first of all we have to understand the experiment, which is the cathode ray experiment. So I must tell you the basics of this particular part before discussing this entire setup, which is looking like a random type of arrangement. So basically, there were different scientists who were actually busy to do or to experiment about the nature or conducting nature of gases. So the main theory or the main experimentation of this fundamental particle, which is electron, started with the discovery, or I can say the experiment, which shows the conductivity of a particular gas. And the scientist who was working on that particular experiment was William Crook. So this scientist, which is William Crook, actually was experimenting about the conducting nature of gases. So he actually made a setup. He made a setup with a glass tube, and in that glass tube he actually had certain type of gases. So you can take hydrogen gas, you can take nitrogen gas, you can take neon, you can take helium. So he was experimenting the conducting nature of gases at a low pressure. So he made the setup, which is basically this type of a tube, which is a glass tube. Now in this particular case, the experiment was very easy. What he was trying to actually get the idea that gases are conducting or not. So generally we know, like, there is no chance of conduction in case of gases, because for the conduction we need the presence of either electrons, protons, or I can say some ions which can actually carry the charge from one point to another point. So in case of gases, you know, like, there is no separation of these charges. We didn't know about the presence of ions at that time. We didn't know about the idea of electrons, protons, or anything like fundamental particles. So he was just simply trying to prove that gases are going to be conducting in nature when we are experimenting the entire part at very low temperature. So he decided to make a setup which is a glass tube, and in this glass tube certain gases are present, and he connected this glass tube to vacuum pump. Now what is the work of this vacuum pump? To create a very low pressure. To create a very low pressure. So everything was connected. Now in that case, for conductivity part, like, how can he check that gases are conducting in nature? He need to attach the entire setup with electrodes. So he took certain electrodes. First one is the cathode and next one is the anode, and their charges as well as the nomenclature of electrode was decided by Benjamin Franklin. So I'm just giving you this entire part in theoretical portion, but this part is very interesting. Just listen to me very carefully. So he was trying to prove the conductive nature of the gases. So he made a setup of a glass tube which consists of a certain gas connected to the vacuum pump to create a very low pressure, and then he connected the entire setup with the electrodes as well as battery to check, like, that we have a flow of charge or something like that. Now in that case, he also needed to provide the high voltage. So then this entire setup was connected to a high voltage system so that he can provide that high voltage. Now the basic experimentation started with this particular part, and he saw that at very low pressure you can see a specific type of ray, is emitting from one electrode to another electrode. He saw that particular part. Some glowing rays were actually emitted from one electrode to another electrode, and that's why he called it as emission rays. So the initial name of this cathode rays were emission rays. Okay. Okay, and this entire part is your basically just because of the discharge of certain particles, I can say. So that's why this entire setup was actually named as discharge tube. Okay, I hope all the basics related to the structure is clear to everyone. Now let's talk about the basic experimentation of a cathode rays. Now he took a particular gas, whatever gas you want to take, you can take that particular gas. Let's say we are taking hydrogen gas. Okay, so when the gas is kept at a low pressure, so initially the pressure was set up at 180 m. At 180 m, which is your equal to your atmospheric pressure. At very high voltage, let's say the voltage in that case is, let's say 10,000 volt, okay, which is very high. Okay, so at this voltage and this pressure, there was no emission of anything. There was no emission in this particular case. So he thought like gases are not conducting in nature. Okay, this was the first set of experiment. Then in the second case, he took the pressure as 10 raised to the power minus 2 atm and voltage as same. Now he saw like certain radiations are emitting which are glowing in nature. So he saw that certain radiations, let's say that we have a glowing color. We can take a glowing color, we can make a glowing color. Okay, so let's say this is the part. So he saw some glowing color which is moving in one direction, So he thought at this particular pressure and the same temperature, glowing, or I can say some type of emission was happening. Now he took the entire part at very low pressure, which is approximately 10 raised to the power minus 4 atm, which is very low pressure. Now in that case, the voltage was again 10,000 volt, which is very high. Now in that case, when gas is kept at a low pressure and high voltage, discharge in a discharge tube. Now you know the basic idea of this discharge tube. Gas starts conducting electricity because they ionize, but they didn't know about the idea of ionization. They had no clue about the ionization process, but we know that gas actually starts conducting electricity because of the process of ionization. Now to understand this particular part, let me tell you the basic analysis of the entire experiment. Let me tell you the basic answer of this entire analysis, because we know that if I am taking hydrogen gas, and I have connected this hydrogen gas to a vacuum pump, it means in that case pressure is low. If the pressure is actually very low, the movement between the gases is going to slow down very slow. Okay, the movement between the gas particles is going to be very slow. They are almost in their specific mean position. Now at that particular pressure, which is very low pressure, when I'm applying the high voltages, it means this positive and negative charges are going to work. It means this particular electrode has that much of voltage. It means it's going to attract, it's going to break down that particular atom. So first of all, what happened, you can see that this H as well as H bond is going to break down into H atom. Now if this fundamental atom which is supposed to be indestructible as well as indivisible, you cannot see any conductance. You cannot see any conductance. But if this atom actually consists of some positive particles as well as some negative particles, you can see the positive particles are going to move to the negative direction and the negative particles are going to the positive direction because they are attracted to the opposite charges. I am applying that much force, I am applying that much voltage. It means it's going to tear down into its fundamental particles. If this atom consists of some positive particles as well as some negative particles, definitely the atom is going to break down into two parts and corresponding particles. Positive part will go to negative electrode and negative part will go to positive electrode. That's the basic idea about this entire experimentation, and that is why you can see the conductance of a particular gas, because it consists of certain positive as well as negative particles. This experiment was only focused for the negative particles because they didn't know about the particles which are positively charged present inside a particular gas. So they thought that if the gas is conducting in nature and we are seeing that some rays are appearing, they are actually originating from a particular side to another side. They thought that these rays are actually emitting from your cathode and they are moving towards the anode. The negative charge electrode is cathode and the positive charge electrode is actually anode. Okay, so they thought that some rays are appearing or they are originating from cathode and they are moving towards the anode. So they named it as cathode rays. But the experimentation was very easy. At very high voltage, at very low pressure, the corresponding subatomic particles, which are your electrons and protons, just because of their different charges, they are going to split and they can move to the different side of the electrodes. I hope this part is clear. So in this experiment, the main focus was this negatively charged rays. So you can say these are negatively charged rays. Now, whatever I told you, they didn't know about this particular idea because they thought that something is actually happening at this particular electrode. Something is happening at this electrode. That's why some negatively charged particles or some negatively charged rays are moving towards the anode. They didn't have the idea that somewhere in between you have a hydrogen and this electron is moving towards this side and something positive part is moving on this side. They didn't have any idea. I'm telling you this particular part so that you can get the entire experimentation, because this experiment becomes very, very boring if I will only explain you about the setup like this is the discharge tube and something is moving towards this anode and let's say this is called as a cathode rays and we can say certain properties of this cathode. It becomes very monotonous. So let's try to decode the idea of that particular scientist who was dealing with this particular experiment. So the first experiment actually started with the analysis of a discharge tube, which is basically given to the scientist, that is your Williams Crookes. Now the main experiment related to this discharge tube was done by actually a scientist, very well known scientist, which is J.J. Thomson. That's why we know that the entire credit to the discovery of electron goes to the J.J. Thomson, because after I can say 10-20 years, he also made or he also used the discharge tube which was made by Williams Crookes, and he did the same type of experiment to know about the nature of these rays which are supposed to be emitted from cathode and they are moving towards the anode. Okay, so that's why these rays were named as cathode rays. I hope the first part is clear to everyone. This is the simple experiment related to cathode rays. Okay, and it's a very useful experiment, because in earlier times when I was in, I guess in first, second class, or up to, I guess when I was in 5th, 6th class, I guess the formation of TVs, you know, like that big box TV. So we have a front screen, and if you look at the behind, you can see a large type of a tube which is supposed to be present inside the TV, and this is the only part which is actually relevant to that application. In previous TVs which were actually started in 1900 to up to 2000, I guess, they were actually made by these cathode rays. Okay, so the cathode ray tube was actually present in the TV. So yeah, it has a practical application also. So this is the entire part about the basic setup of the cathode rays. Now, some invisible rays, because we know that at very low pressure, which is approximately 10 raised to the power minus 4 atm, you cannot see the rays. They were glowing in the earlier cases when the pressure was not that high, not that low, but at very low pressure they were not glowing. So to check about their nature, if they are actually moving from, or if they are supposed to move from cathode to anode, what they did a specific thing. They used a perforated anode, or they made some holes into the anode part. So if something is actually moving from cathode to anode, if something is moving from cathode to anode, and we cannot see because now it's not visible, so I need to make sure that something is moving. So I can make small holes into the anode, which is perforated anode, and I can actually coat the back side of this glass tube with a specific chemical, which is basically your ZNS. Now they coated the back side of the anode or the glass tube with a specific chemical, which is a ZNS, which is zinc sulfide. Now it has a specific property. Whenever any charged particle is going to hit on that surface of a ZNS, a spark is going to produce, and that spark is actually known as scintillation. And this effect is scintillation effect. So what they did, some invisible rays move from cathode to anode. As the rays seem to be originating from cathode, they actually termed as cathode rays. But we know, like, this idea is not true. This idea is not true. They thought that they are appearing they thought that these rays are supposed to be originating from cathodes and they are moving towards the anode. So they termed that particular part as cathode rays. But you know, like, this is not originating. In actual, these are not originating from cathode, but it is basically an atom of hydrogen which is splitting, or which is going to ionize. So this is nothing but the ionization, that the electrons or negatively charged particles are moving in this direction and some positive part is moving in this direction. So in actual it is nothing but the ionization of gases. I hope this part is clear. Okay, so we know about this entire analysis. Now the next portion. We got the idea how the name of cathode rays were actually derived, because at that time they didn't have the idea about the ionization phenomena. They thought that something is originating from cathode and it's moving towards the anode. Now if there is nothing, if at low pressure, if it is not glowing, we can make it as a perforated anode and we can make a fluorescent coating of ZNS. So whenever these charged particles are going to strike on the surface, a specific effect is going to originate, which is known as the scintillation effect. So the spark producement. Okay. Now if I talk about the basic property analysis, and that property analysis part entirely goes to J.J. Thomson, because he was studying that particular part, like what is the nature of these rays, whatever producing in the experiment, discharge tube experiment. So first of all, he said that cathode rays travel in a straight line with a very high velocity and produces a shadow of the object whatever placed in their path. So if something is not moving in the straight line, definitely you cannot see any type of shadow formation. For example, very common application of this part is whenever sunlight is actually hitting our body, and when we are moving on a road, you can see a shadow is actually appearing in the region where I am actually present. So it means if something is actually traveling in a straight line, so for example, if this particular part is traveling in this straight line, it's not going to penetrate this entire part. So you can see a shadow formation. So the first application was very easy, that cathode rays always travel in a straight line with a very high velocity. I hope this part is clear. Now, what are the other properties? What is the nature of these rays? They can be solved with the help of another type of experiment. So everything was happening inside this glass tube, inside this discharge tube. We were using different type of objects to see the nature of this particular gas. So in that case, they produces a mechanical effect. What is the behavior in that case? Definitely it consists of particles. It consists of particles, because only particles have the tendency to produce a mechanical effect. But sir, what is the meaning of mechanical effect? So let's say the actual game, which is bowling. You know that bowling, we have to throw a heavy ball, which is supposedly of iron, I can say, or some other type of combination. And when that particular ball is going to hit the target, there are 9 or 10, you can say, some bowling apparatus or whatever it is. I don't know the exact name, nomenclature of that particular part. If you know the nomenclature, just let me know in the comment box. Okay, so I'll try to incorporate that part in the next class, definitely. So when you use that particular heavy ball and you are striking that particular ball to the target, you can see the target is going to smash down, like it's going to scatter, because that ball has a mechanical effect. It has certain mass, and when it's going to hit something, definitely you can see that part is going to move. So that's why when we are moving a very light paddle wheel in front of these rays, you can see the movement, or this wheel is going to rotate, which shows that if something has a mass, definitely when it's going to strike, it can actually change its path. It can actually change its path, which is the mechanical effect. Okay, if something is wave nature, definitely it can pass through, it can go to that side, and it will not affect the paddle wheel. But these cathode rays shows the mechanical effect. It means this paddle wheel actually starts rotating. You can see the rotation. So that shows that they actually consist of particles which has small amount of mass. I'm not saying that mass is going to be very, very large, but yeah, it has some mass. Okay, I hope this second part is clear. So first part, they travel in a straight line, they have a specific mass. What is the value of that mass? We don't know. We don't know till now. Okay, so after completing this experiment, I'm going to tell you like what is the actual mass of that particular particles, whatever moving in the cathode rays. Okay, so the next part was to check the nature of that rays. Were these rays negatively charged or these were positively charged? So they actually connected the entire setup with an electric field having positive charge as well as negative charge. So they connected the entire part with electric field, as well as they tried the same experiment with magnetic field also. So some magnets were also there. So let me tell you the first idea about the electric field. So when the electric field was applied in the path of these rays, I had the anode which was perforated so that I can see the scintillation here, and we had some electric field in between the path, and again this particular part was scintillated, like it has a certain coating of ZNS. Now when I applied the electric field, they saw that this movement, like this motion of these rays were actually towards the positive terminal, and they saw certain scintillations on this side only, which shows that if something is negatively charged, it can only attract to the positive charge. So they thought like this particular part, when electric field and magnetic field is applied, these rays shows deflection. In case of electric field, they show the movement towards positive terminal. It means, what is the meaning here? It means that rays are negatively charged in nature. Okay, I hope this part is clear. Now they travel in a straight line, they have certain mechanical effect, and they are actually negatively charged in nature. Now the next thing is their specific charge to mass ratio, which is a specific charge, I can say, that is charge to mass ratio is the same for all type of cathode rays irrespective of the gas used in the tube. So when I am using hydrogen H2, when I am using helium, when I am using neon, whatever gas I am using, every time the charge to mass ratio, this was constant, this was constant. It means every time when I'm ionizing this entire part, same type of thing is actually originating from one electrode to next electrode. The main conclusion from this particular part, because we know that if I'm taking hydrogen At high voltage, it's going to be converted into hydrogen atom, and after the ionization, it will convert into H positive as well as electron. Same experiment if I am using with, let's say I can take F2. Again, it's going to break down into F. Again, it's going to be converted into F positive as well as electron. Although this experiment is not very fair to write, because we know like fluorine is not easy to ionize. For example, I can take any other radiations like X2 I'm using. It will convert into X, and after the ionization it will convert into X positive as well as electron. So every time after the ionization, you can see there is a removal of electron. If the removal of electron is happening, it means electrons are same for every type of atom, either it's hydrogen, helium, neon, argon, whatever it is, the electrons are same. So it means their nature is going to remain constant whatever the source I am taking. So if I am using hydrogen gas or helium gas or neon gas, whatever gas I am using, every time this charge to mass ratio is going to be very specific, and it's going to be same, which shows that cathode rays, whatever source I am taking, cathode rays are always same. So cathode rays are independent of the source, okay, which shows that their charge to mass ratio is going to remain constant. So how can we talk about the charge to mass ratio? The idea is very easy. This charge part corresponds to the application of electric field, and this mass part is basically related to magnetic field. So we had that application. When I'm applying the electric as well as magnetic field, we can see the deviation. Now when I'm applying the electric field, they show the deviation towards this positive part. So I'm using the same experimentation, although my drawing is not that good. So just bear with me. This is the experiment of your part, which is basically it was supposed to be your cathode ray, let's say. Okay, so in this particular case, this is the electrode in which they are connected. Okay, and some rays were originating from this particular part. Some rays were originating from this particular part. Some rays were originating from this particular part. Now I am applying the electric field. You can see the deviation on this side. You can see the deviation on this side. You can see the deviation on this side. Okay, when I am putting the, this is your positive part electric field, this is your negative part of electric field, and I can also apply magnetic field. I can also apply magnetic field. When I am applying the magnetic field, you can see the deviation on this side. Now this deviation of magnetic field depends upon their mass, and this deviation of electric field depends upon their charge. Okay, now in that case, when I'm balancing these values, I can also make it as a straight line when this entire part is balanced. Okay, so this first part is related to electric field. This second part of radiation is related to magnetic field, and after balancing the part, after balancing electric field as well as magnetic field, you can see this third type of radiation, which is undeviated. So you know the values of a magnetic field, you know the value of electric field, whatever you are applying, and you know you made it like a balanced situation. It means charge, which depends upon the electric field, as well as magnetic field, which depends upon the mass. They are actually balanced, and for every type of gas, we were getting the balanced value. It means it simply said that this entire portion is going to remain constant. It's going to remain as it is. This is the basic idea about the cathode rays, which shows that whatever gas I'm starting with, every time their nature is going to remain constant. It means their specific charge is going to remain same. I hope this entire part is clear to everyone. This is the basic portion related to the properties of your cathode rays, and I hope I was able to explain the entire part in the simplest manner possible. And if you guys are facing any difficulty, if you have any doubt, sir, this part is not clear, or this portion we were unable to correlate, just drop a comment and I'll explain that particular part in the next class. Okay. Okay. Now next part is, if we talk about this E by M ratio, we got the value as approximately equals to 1.76 multiplied by 10 raised to the power 11. This is capital C, Coulomb per kilogram. Okay, Coulomb per kilogram. First part was from electric field, next part was from magnetic field. Now, this part was this part was discovered, or this part was explained after the Mulligan's experiment. And that Mulligan experiment was able to explain about the charge of electron, and after the charge we know the specific charge of that electron, or whatever cathode rays we are considering, we know about the charge of electron, so we can easily calculate the mass of electron, which came out as 9.1 multiplied by 10 raised to the power 31. Now the main thing is, sir, what is Mulligan's experiment? How can we explain this entire part? So again, the Mulligan experiment was known as the Mulligan's oil drop experiment. So the experiment was very easy. He took some oil droplets. He used a particular apparatus to create the droplets of oil. So we know there are the different type of sprinklers which can actually produce the mist of a particular liquid. So we had the mist of oils, and in that case there were small droplets of that particular oil which was supposed to be targeted on a closed chamber. And again, in that chamber you had two different plates. So you had two different plates. First plate was like this, and a small hole was there, and next plate was like this. Okay, and this plate was negatively charged and this plate was positively charged. So he sprinkled mist of oil, and some oil droplets were actually settled down on this plate, but some of the droplets are actually went through this particular hole, and he was checking the speed by which they are actually settling down in the on this particular plate, which was your positively charged plate. Now when he applied different amounts of electric field, he actually saw the different type of speeds by which these droplets are actually going downwards. Okay, so by changing the electric field, you can read out the experiment in NCERT also. It's also given in the different color. I guess green color is there, so you can see a different section related to Mulligan's oil drop experiment. You can read out that experiment. I am trying to explain this particular experiment with the simplest way possible. So like, he was checking the speed by which these droplets are passing through this small hole and they are settling down on this particular plate. Okay, he was checking the speed. Now by varying the electric field, he saw a change in the movement of these droplets. So there were some droplets which were moving very slowly at a specific value of electric field, and some droplets were moving very fast. And every time he was changing the electric field, he actually saw the change in their speed of settling down. And from that calculation, he thought like something charge is definitely present, and if I am applying that much high electrical voltage, definitely some ionization is going to take place, and in that case this entire settling down of the rays or these oil droplets depends upon the charge of that particular droplet. And every type of oil, if I talk about any type of oil, it consists of atoms definitely, and every type of atom consists of electrons, but the number of electrons are actually different. So every time that charge, he was saying, like whenever he was applying some electric field, he saw a different speed. It means the one thing which was constant, that every time I am applying the electric field, this electric field application, which depends upon the movement of that particular droplet on the positive or a negative plate, he was saying that is something a whole number multiple of a specific thing. It is the whole number multiple, because we know that every type of atom, if I talk about the hydrogen atom, it has only 1 electron. If I'm talking about helium, definitely 2 electrons. If I'm talking about lithium, 3 number of electrons. So let's say I'm using, first time I'm using the droplets which contains hydrogen. Definitely in that case only 1 electron is there, so definitely its movement is going to be different. In second time, let's say I'm using the electrons which are supposedly to emit from helium, 2 number of electrons, definitely the movement becomes twice. So it means whatever electric field I'm applying, it depends upon the a specific number and there is a multiple of that number. It simply suggested that whatever n value I am using, it depends upon the number of electrons, but this part was constant. This part was constant and its value was 1.6 multiplied by 10 raised to the power minus 19. Okay, this particular part was 1.6 multiplied by 10 raised to the power minus 19 coulomb. Now he thought that if I am using the whole multiple, I can talk about the one single unit, and he said that the charge of whatever species is present inside that particular part, which is definitely electron, is basically 1.6 multiplied by 10 raised to the power minus 19 coulomb. This was the Mulligans experiment. I hope this part is clear. I hope this part is clear. Now definitely we know that electrons are negatively charged, so this charge is going to be -1. But if I am talking about the magnitude, magnitude is going to be 1.6 multiplied by 10 raised to the power minus 19 coulomb. So if we know the charge, we know the E by M ratio, we can put the value of E, we can calculate the M by dividing E with this number, and we can easily calculate this entire part, and we got the mass of a first fundamental particle, which was electron. And J.J. Thomson is the only scientist who was working on the discovery of this fundamental particle. So that's why we know that whenever we talk about the electron, the main credit goes to J.J. Thomson. But there were different scientists, you know, the charge part goes to Mulligan, the discovery of a discharge tube or emission rays goes to Williams Crook. The name of these electrodes were given to the Benjamin Franklin. So you know, like it's a combination or it's a cumulative discovery of different type of scientists. I hope this entire portion is clear to everyone. We know about the entire concept. It's nothing. The cathode ray experiment was very easy. It's nothing but the ionization of gases, and during the ionization definitely positive part and negative part is going to emerge. It's not that the gases are emerging from a particular anode or cathode. They are supposed to be originating from cathode or anode, but the actual analysis is the movement of subatomic particles towards the different type of electrodes when we are applying high electric field. I hope this entire portion is clear to everyone, and that is nothing but the discovery of electrons. Just look at it. We will discuss the next portion immediately. Okay. Okay. Now the next part was the discovery of protons, and the main credit goes to Goldstein. So after the discovery of cathode rays, they thought like if we have this same experiment, the same experiment of cathode rays, like we have the same discharge tube, we have the same discharge tube, we have the same type of gas, okay, we have the same conditions. Same conditions means we have very low pressure, very high voltage. If we have the same type of conditions. Now instead of using a specific part of anode, I am using perforated cathode. Now instead of using the part of anode, now I am concerned about the perforated cathode, and let's see what is going to happen. So again, in this perforated cathode you can see small holes which are present in the electrode. What happened? The observation was same. The observation was same. Let's say I am again using a fluorescent coating on the cathode side. Now I am using the fluorescent coating on the cathode side. So again I can see some rays are appearing, or they are originating, or they thought that they supposed to be originate from anode towards the cathode. Now we have a perforated part, definitely they can again move in the straight line, and they are moving through this particular part like something is traveling from a tunnel. Okay, like let's say you are going to Manali, or you want to go to Laul Spiti, you know you have to move to the Atal tunnel. So you're moving your car in a straight line and crossing the tunnel, and you can see after crossing the tunnel you have the border of Laul, and that particular part, it means you are moving through to a straight line. Although this explanation is very lame, but you can relate if you know, like if you visited the Atal tunnel, then you know this particular part, that something is traveling in a straight line and it's moving through this particular perforated hole towards the next side. So that's why, like, there was a different name which was also derived for anode rays, which is canal rays. So something moving from a tunnel like thing, that is the canal rays. So again the experimentation was same, everything was same, but the thing is, now instead of using anything towards the anode, I am changing the cathode. I am using a perforated cathode having small holes, and I am seeing that some rays are supposed to be originating from anode, and they are moving in a straight line towards the cathode. And again you can see a scintillation effect on the fluorescent coating which is actually present behind the cathode. So the experimental setup was exactly same. If you know the cathode ray experiment, you know the anode ray experiment. Okay. Now, when a gas is kept at low pressure and high voltage in a discharge tube, gas starts conducting electricity because of the ionization. Same type of explanation for this part also. Same type of explanation. Now, the experimental setup was also same. But in this case, now you have this perforated cathode. So in this case, you can see the rays consisting of a positively charged particles are produced due to the ionization of gas present in the discharge tube, and they named them as canal rays or anode rays. I hope this part is clear to everyone. You can see again these rays are having positive charge because let's say hydrogen is present. After the ionization, negative part is going to move towards this side and positive part is going to move towards this side. So it's nothing but the ionization of gas. That's it. That is the only phenomena is happening here. Okay. So the main part of this particular gas analysis is slightly different from all the parts of cathode rays. First part is very easy, like mass of positively charged particles. Now, before discussing this first portion, I can say they move in straight line, first part, like your anode cathode rays. Second part, they have mechanical effect. Okay, done. They have mechanical effect, done. They move towards negative terminal on applying electric field. Okay, so these are the three things exactly same to the cathode rays. So they move in a straight line. So if you are placing any object in their path, you will get the shadow. If you are placing any soft pedal wheel, they start rotating. And now in this case, when you are applying the electric field, now these are positively charged. So definitely they show a deflection towards the negative terminal, which shows that they are positively charged in nature. Now the main thing which was different, these 2 points were actually different from cathode rays. These 2 points were entirely different from cathode rays because let me tell you. So let's say I am using hydrogen. Hydrogen contains electrons as well as it contains one proton which is positively charged. One proton which is positively charged. Now I am using helium, let's say. Helium again contains electrons. it contains protons which are positively charged, and it also contains some neutrons, and it becomes slightly heavy. It becomes slightly heavy. Okay, let's say I am using beryllium. Again, it contains electrons, it contains protons, and it contains neutrons. It becomes more heavy. Okay. Now, let's say I am using hydrogen, and after ionization you will left with H positive plus electrons. Let's say I am using helium. After the removal you will left with, let's say, He positive as well as electron. Let's say. Now, in this case, this a positively charged part, whatever positively charged part I am using, every time negatively charged part is electron only. This negatively charged is electron only. But what is left inside that particular atom, you will left with the positive part, which is not always proton, which is basically the nucleus. So you will left with the nucleus, and every type of a nucleus is different, because you can see, you can compare helium as well as beryllium nucleus. Helium nucleus is slightly light, but the beryllium nucleus is slightly heavy because it contains positive charge just because of the presence of protons, and protons are different. The number of protons are different, but again there is a presence of another heavy particle, fundamental particle, which has no charge, which is basically neutron. So you can see, every time I am using different type of a gas, every time the mass of a positively charged particle depends upon the nature of a gas present in the discharge tube, and the reason is, every time nucleus is a different. Nucleus is a different, because electrons are same for any type of atom. For helium, electrons are same. For beryllium, electrons are same. For lithium, electrons are same. Everything is same. But every time helium nucleus is different, beryllium nucleus is different, lithium nucleus is different, carbon nucleus is different. It means every time the mass of that positively charged particles is actually depends upon the type of gas I am using. In the same way, the charge to mass ratio is again going to change, because the charge to mass ratio, mass is changing. In that case, you know, this charge is the same, but the mass is actually different. So this charge to mass ratio actually always depends upon the nature of the gas taken, because every time mass is going to be different. I hope this entire part is clear. So this is the basic difference between your cathode rays as well as anode rays. Just have a look at it. Very simple explanation, very simple explanation. And if you find any difficulty, just drop a comment and let me know. Okay. Okay. Now next part is when electric field and magnetic field applied, they show deflection, because we know that they are positively charged. So definitely they are going to show the deflection. So when they deflect towards the negative plate, when kept in the electric field, we show that the actual result in that case is very easy, that they are positively charged in nature. So basically the discovery of anode rays was not dedicated to protons only, but it was talking about the presence of some other type of particles. Now because we know, like, the entire experimentation of these anode rays was not the exact idea about the discovery of protons. So we need to understand what is the actual subatomic particle which is present with a proton inside the nucleus. So that is basically the discovery of neutrons. So first of all, neutrons are no charge species. They have no charge, but definitely they have some mass. They have some mass. Now in the same experimentation, like this type of experiment, when they applied the electric field, they saw the deflection towards the negative terminal. When they applied the magnetic field, they saw the deflection towards the another side, and when they balanced this particular part, they got the straight line, just like the same experiment they did previously. And they found out that when we talk about the charge in this case, charge is exactly same as electrons. But in that case, the charge is positive charge, because we are talking about the positive charge rays. Now in this particular case, how they calculated the charge? Every time they are using different type of gas, they are getting a multiple, same multiple of a same number, which is 1.6 multiplied by 10 raised to the power minus 19 Coulomb. So they thought like something is common in this case, so the charge is going to remain as it is, and it's a multiple of that particular part, because every type of nucleus contains different type of different number of protons. Helium has only 2, lithium has 3, beryllium has 4. So this n value is going to vary accordingly, and whenever the application of electric field is going to apply, which depends upon the charge only, it is a whole number multiple of a specific number, which is 1.6 multiplied by 10 raised to the power minus 19. So they thought the charge is going to remain same, but it is opposite to the previous part, opposite to the cathode rays. So we can say this charge is going to be positive. So it is positive 1.6 multiplied by 10 raised to the power minus 19. But this E by M ratio was not fixed. So they were unable to calculate the mass of that particular subatomic particle, because it consists of protons as well as neutrons. That's why they worked on the discovery of neutrons. But remember, this discovery of neutron took large, like I'm not sure about the years, but it took almost 10 to 12 years to understand the nature of neutrons, because before the discovery of neutrons, there was a discovery of radioactivity took place. Okay, so scientists were working on the radioactive elements, and you know, a very well known scientist, Madame Curie, as well as his husband, they were working on the applications, and they were working on the radioactive elements, and they found out that in every type of radioactive element, they actually emits certain radiations. So you know, everything is connected, everything is connected. They emit certain radiations. Some radiations are positively charged, some radiations are negatively charged, and some radiations have no charge. They called them as alpha rays, beta rays, as well as gamma rays. So this was already established that when we are taking any type of radioactive element, so definitely you can see some emission of alpha rays, which are positively charged, emission of negative rays, which are your beta rays, and there is also emission of no charge rays. Now the same experiment was done for the discovery of neutrons. They were not discovering the neutrons, they were experimenting the same type of experiment for radioactivity. So basically this entire part goes to Chadwick. So actually Chadwick took a very thin sheet of beryllium, and he bombarded that particular part with alpha particles, because alpha particles were already discovered at that time. So you know, like this experiment was done in 1932, and the entire part related to your cathode rays or anode rays, they were in the year of 1896, I guess 1896. So you can see a enormous amount of time which was spent on the discovery of radioactivity. So the electrically neutral particles that were emitted had slightly greater mass than the protons. So basically the experiment was very easy. Chadwick used alpha source, which is basically a source which emits alpha rays, and alpha rays are positively charged. Alpha rays are positively charged in nature. Now there was a beryllium thin sheet, and they had the idea about the positive part, negative part. They had the idea about a positive part, they had the idea about the negative part, that every atom actually contains positively charged particles as well as negatively charged particles, named as electrons as well as protons. Now when they bombard it with the atom, so let's say this is the alpha particle, which is positively in nature. This is the alpha particle. This is the alpha particle. Okay. Now when it is going to bombard on a particular atom containing a positively charged particle, a negatively charged particle, and one neutral particle. Okay, one neutral particle. So definitely this positive and positive, they are going to repel each other. And they took a screen here. to check the presence of different type of particles. So when this part is going to strike with this particular part, just because of the repulsion, it's going to strike on this side, let's say. When this part, this alpha particle is going to strike on the negative part, they both are going to combine together, and this part was like this on applying the electric field. So this was the application of electric field. You can see a movement towards the positive terminal, movement toward the negative terminal, and after the bombardment on the neutral part, something was also originating, something was also appear to originate which has no charge, because on electric field it shows no deviation, it shows no deviation. So in that case it's no deviation. So they thought, say they thought, because they had the entire idea about the electrons, protons, sorry, alpha rays, beta rays as well as gamma rays. So they thought that after the bombardment, some particles are positively charged particles, some particles are negatively charged particles, because atom consists of these subatomic particles. But they never thought that something neutral is also present inside the nucleus. So they thought whatever no deviation particles are coming, they are basically gamma rays, and they had the entire idea about the gamma rays. So they compared these type of neutral rays which were appearing after the bombardment of alpha rays on beryllium thin sheet. They thought that they are going to be gamma rays, and they matched their values, whatever values they were experimenting at that time, with the known gamma rays which were already discovered by the concept of radioactivity. And after matching those results, they found out like this something particle which is appear to be originating from the beryllium is actually entirely different from the gamma rays. So in that case, the electrically neutral particles that were emitted had a slightly greater mass than the protons. So they thought something else is happening. Something is also present inside the atom. Some neutral particle or some neutral rays which were appearing after the bombardment, they are not gamma rays, because when we are checking the data of gamma rays and the checking of this data, they are entirely different. It means something else is present, and he named these particles as neutrons. It's a very interesting theory. I'm just saying the entire part in a very layman term so that you will get to know, because I can say like they are not that exam relevant. Not many questions are actually basically asked from this particular part, but yeah, you need to know about the basic discovery of electron, proton and neutron so that you can get the idea what is going to happen next. Okay, so after the entire part, you can see the reaction also. So these are alpha particles. We have a beryllium thin sheet. So 4 is the atomic number, 9 is the mass number, and when it is bombarded with the helium nucleus, which is your alpha particles, you can see they are going to convert into another type of a nucleus which is of carbon, because there is a combination is going to take place, and you can see one neutral particle is going to emerge. This is the neutral particle which is entirely different from the gamma rays. So that was your neutron. I hope this part is clear. This is the reaction which comes under the radioactivity part. Okay, a new particle which is electrically neutral but having mass greater than that of proton was obtained and termed as neutron. And that's why every time when you were using different type of gas in the anode ray experiment, you were getting different E/m ratio, because in that case protons are also present, they have mass, but neutrons are also present which has a certain mass, and that's why this E/m ratio was also different for every type of gas. I hope this entire portion is clear. Now we know the entire idea about electrons, protons as well as neutrons. This is the discovery. So to sum up everything related to electron, proton and neutron, we have 3 fundamental particles, electrons, protons and neutrons, denoted by the symbol small e, small p as well as small n. The absolute charge of electrons and protons are exactly same, but their sign is different. For electrons, it is negatively charged, which is 1.6022 multiplied by 10 raised to the power minus 19. For protons, it's same, but in positive term. The relative charge is -1 and +1. And for neutron, charge is not present, so it's 0. Now, if I talk about the mass of proton is approximately 1837 times of electrons. So it's slightly heavy in terms of kilogram. So it's basically in general calculation we take it as 9.1 multiplied by 10 raised to the power minus 31, and for protons it's 1.67262 multiplied by 10 raised to the power minus 27 kilogram, and for neutron it is slightly high, which is 1.67493 multiplied by 10 raised to the power minus 27. So that is all for the discovery of fundamental particles, the Dalton's atomic theory, as well as the basic idea of your atom. I hope like this part is clear to everyone, because after this part we are going to discuss a very interesting portion related to different type of elements which consist of these fundamental particles, definitely. Okay, so in that case, okay. Now the question is, how many neutrons and protons are there in the following nuclei? You know this particular part from the previous chapter also, that is the representation of a particular atom. You know, if I am representing a particular atom, we have the symbol of that atom, then we have we have first part which is Z, as well as the next part A. So this is the symbol, this is the atomic number which is equals to the number of protons. This particular part is basically number of, this is basically mass number, which is basically number of protons plus number of neutrons. Okay, so always remember, for neutral atom, we know that Z value is equal to number of protons, which is equals to number of electrons, first part. And next part is number of neutrons are basically A minus Z. That's it. Okay, so first part is 13C6. So if I am taking the first part, which is 13C6, we know in that case number of electrons as well as number of protons are equal to 6, which is the Z value because it's a neutral species, and number of neutrons in that case are 13 minus 6, which is basically 7. And that's how you can calculate the entire part. I can take another example. Let's say I am taking second example as 88 SR 38. So I can say number of electrons as well as protons are 38 and neutrons are 88 minus 38. So that will be, I guess, 8 minus 8, that will be 50. Okay, and that's how you can calculate rest of the part, which is this portion, and this portion. I am giving you as a homework. Very simple question. I hope this entire part is clear. Now, okay, we have another question. Write the complete symbol for the atom with the given atomic number and atomic mass. Okay, so atomic number is a 17. So we have a 17 X 35. So what is this X? We know 17 atomic number is chlorine. So this particular part is chlorine, and the representation will be 35 Cl17. For that part you need to understand, I told you, you have to remember first 20 elements or first 30 elements as well as their atomic number and their mass number, because it's pretty much required for the calculation. Okay, now next part is 92A is 233. This part is also very easy, but after knowing the entire part of a periodic table, you will get to know like which type of element we are considering in this particular case. So we have a special series which is actinoids, so this is the first part, which is thorium, and this has atomic number 90, then we have 91, then we have 92. So this 92 corresponds to uranium. We have 233 and 92 X. So here X is basically uranium. So the actual representation is 233 U 92. Don't worry if you are not able to answer this question. You will be able to answer this question after knowing about the entire periodic table, which will be discussed in the inorganic chemistry, that is periodic classification. Okay, so don't worry. Next part is Z4, which corresponds to beryllium, A9. So that is, we are talking about the beryllium. Okay, so that is beryllium. Okay, I hope this question is clear. Very, very easy question. Very easy question. Okay, next part is calculate the number of electrons which will together weigh 1 gram. A very interesting question. So the mass of one electron is basically 9.1 multiplied by 10 raised to the power minus 31 kilogram. Okay, or I can say, if I want to convert this part into grams, that will be 28, 29, 20, 30, 31. So that will be minus 28 grams. Okay, that is the mass of one electron. Okay, so in 1 gram, number of electrons are unitary method. So 9.1 multiplied by 10 raised to the power minus 28 gram electrons basically means 1 electron. So in 1 gram, how many electrons are there? This is 1 upon 9.1 multiplied by 10 raised to the power minus 28 electrons. So you can solve this entire part. That will be 10 divided by 91, let's say, multiplied by 10 raised to the power 28. Or I can say it will be 100 divided by 91 multiplied by 10 raised to the power 27 electrons. Just solve this entire part and let me know the final answer. Very simple unitary type of calculation. Okay. Calculate the mass and charge of 1 mole of electrons. Okay. Second part. Charge of 1 electron is basically 1.6 multiplied by 10 raised to the power minus 19 coulomb. Charge of 1 mole of electrons will be number of electrons in 1 mole multiplied by charge of 1 electron. So that will be 6.022 multiplied by 10 raised to the power 23 multiplied by 1.6 multiplied by 10 raised to the power minus 19 coulomb. Just solve it. And if you know the charge part, same goes with the mass also. Mass of 1 electron is 9.1 multiplied by 10 raised to the power minus 31 kilogram. So for 1 mole, that will be number of electrons in 1 mole multiplied by mass of 1 mole. That will be 9.1 multiplied by 10 raised to the power minus 31 multiplied by 6.022 multiplied by 10 raised to the power 23. So again, this question is your homework. Solve it and just let me know the answer in the comment box. Okay, very simple question, very basic question. Okay, so I told you like this lecture is very basic. So that's why we are discussing all the questions related to the basics part. Okay, calculate the total number of electrons present in 1 mole of methane. Okay, a very interesting question. So methane is basically CH4. Okay, so I can say number of electrons in 1 molecule of methane will be number of electrons in carbon plus 4 multiplied by number of electrons in hydrogen. Okay, so I can say in carbon you can find 6 electrons plus 4 multiplied by 1, so that will be 10. So in 1 molecule of CH4 you have 10 electrons total. Okay, and calculate the total number of electrons present in 1 mole. So in 1 mole CH4 you have 6.022 multiplied by 10 raised to the power 23 multiplied by 10. That will be 6.022 multiplied by 10 raised to the power 24 electrons. Okay, because in 1 mole we have 6.022 multiplied by 10 raised to the power 23 CH4 molecules, and in 1 molecule you have 10 electrons. So very simple calculation. So this is your first part. Okay, second, find the total number and total mass of neutrons in 7 mg of 14C. Assume that the mass of neutron is 1.675 multiplied by 10 to the power 10 minus 27 kg. Okay, very interesting question, but a slightly lengthy calculation. Okay, so basically in first part I can say in one atom of carbon 13, okay, sorry, carbon 14, carbon 14. So this will be 6C14 definitely. You have 6 electrons, you have 6 protons, but you have 8 neutrons. Okay, so you know about the one atom. If you know about the total number of atoms, the entire calculation will be very easy. So the question is asking about the different portion. Basically, it's talking about the total number as well as total mass of neutrons. So first of all, to calculate the total number of neutrons, we need to know that what is the actual mole and how many atoms are actually present in 7 mg of this carbon. We need to know that how many moles or how many atoms of carbon 14 are actually present in 7 mg only. So that's how we can proceed for this question. So first of all, if I talk about the number of moles of carbon 14, that will be given weight divided by the molar mass. Now given weight is 7 mg. So that will be 7 multiplied by 10 raised to the power minus 3 grams divided by, now I cannot use a 12 gram because we have carbon 14, so I have to take it as 14 gram. Okay, so that will be 0.5 multiplied by 10 raised to the power minus 3 moles. Now we have a moles, this many moles. So from that part I can say number of carbon 14 atoms in 0.5 multiplied by 10 raised to the power minus 3 moles will be number of moles multiplied by Na, which will be 0.5 multiplied by 10 raised to the power minus 3 Na. So these many atoms of carbon are present, and in one atom you know 8 neutrons. So total neutrons, total number of neutrons are basically 0.5 multiplied by 10 raised to the power minus 3 Na multiplied by 8. So that will be 4. So 4 multiplied by 10 raised to the power minus 3 Na will be the total number of neutrons. Mass of one neutron is 1.675 multiplied by 10 raised to the power minus 27 kg. So this total neutrons have the mass, which is these numbers multiplied by mass of one neutron. So that will be 4 multiplied by 10 raised to the power minus 3 multiplied by Na. Na is 6.022 multiplied by 10 raised to the power minus 10 raised to the power 23 multiplied by 1.675 multiplied by 10 raised to the power minus 27. So we can say from this particular part, total mass of neutron will be total number of neutrons multiplied by mass of one neutron. So that will be 4 multiplied by 10 raised to the power minus 3 Na multiplied by 1.675 multiplied by 10 raised to the power minus 27 kg. That will be the final answer. Just solve the question and let me know the final answer. So this will be your homework. Just solve this question by yourself. Okay. Find the total number and the total mass of protons in 34 mg of NH3 at STP. Okay. And will the answer change if the temperature and pressure are changed? Okay, so it's a very interesting question. First part I am giving you as a homework, which is similar to the previous part. So this is your homework. Now the second thing is, if I talk about the number of moles in that particular case, always remember in this particular case, will the answer change if the temperature and pressure changed? So in that case, if I am using the sample as 34 mg, this particular mass, whatever I am using, it's going to remain as it is. If volume was there, definitely with respect to volume, the number of moles are going to change, because in case of a volume, you know the formula that number of moles of any gas will be equal to volume of gas at STP divided by 22.4. So with respect to that part, you can see the answer is going to differ, but we have the given weight here, so it's not going to change. So we have the same answer. Okay, I hope this part is clear to everyone, and let's move to the next part. Okay. Okay. Now the next part is related to the waves. Why we are discussing the wave part, like we were discussing about the portion of discovery of particles, and you know the entire discovery of particles goes to cathode rays as well as anode rays. So we are talking about the rays, first part. So that's why we need to understand the basic behavior of waves in that case. Second part, when they used the same experiment of cathode rays as well as anode rays, so they knew that we are talking about the emission of electrons as well as emission of protons. When they did the same experiment, that is the emission of electrons from a very small hole, they saw a diffraction pattern. In that case, they saw diffraction pattern. So to understand the diffraction, which is basically a prominent wave nature, which is prominently a wave nature, when they saw the same experiment that the electrons are emitting, and when they are emitting from a small hole, they show a diffraction pattern. So it means it corresponds to wave nature. So to understand the basic behavior of these cathode rays, anode rays, or electrons or protons, we need to more focused on the basic idea of a wave. So that's why we need to understand the basic behavior of waves. And if I talk about the waves, basically wave is a very simple term. It is nothing but the mode of transfer of energy without a transference of matter. So always remember, in that case, that's why the properties of a wave are entirely different from a matter, because in that case you are not exchanging the matter, you are simply transferring the energy. So it's a mode of transfer of energy without the transference of matter. I hope this part is clear. So you know, like you have the basic idea about the waves from physics. You saw certain type of waves. We have like this type of waves. This is the nature of wave. Every time you can see a different type of wave depending upon their characteristics. So to know better about a particular wave, either it's electromagnetic wave or it's any type of wave. So in physics, you have the entire portion related to wave. I'm not going to go deep inside the idea of a wave. For chemistry, we just need to understand the basic characteristics of wave, how you can differentiate one wave with respect to another. So you can see, like, there are 4 type of waves I am showing you, but these 4 waves are entirely different from each other. So in what respect we can say that these rays or these waves are actually different from each other? So in that case, we need to understand some basic characteristics related to waves. First part is your wavelength. First part is your wavelength. Next part is your wave number, then frequency, then amplitude, and then velocity. If you know about this particular part, wavelength, which is lambda, wave number, which is basically nu bar, frequency, which is a nu, amplitude is A, velocity is V. If you know about all these things, you can easily characterize a particular wave. Standing wave, moving wave, transverse wave, longitudinal wave. So in physics, you have the entire portion related to wave, but in chemistry, we are going to be more concerned about these basic parameters so that we can differentiate different type of waves. And after completing the entire part, we are going to discuss about a very basic wave which we all know from the starting part, that is your electromagnetic radiation. And we are going to start with sunlight only, because we have the major source of light, which is your sunlight. So definitely we are going to correlate the entire part with sunlight so that we can get the entire idea about the wave nature here. Okay, now if I talk about the first term, it's very easy. Wavelength. Wavelength is basically, if I'm talking about the movement of a particular wave, we don't know the origin definitely. So in that case, if I'm talking about the upmost portion, they actually goes to the maximum peak and then they move towards the minimum part, minimum peak. So the maximum portion is basically known as crest in that case, in case of a wave, which is a moving wave definitely. And the lowest peaks are basically known as troughs. So wavelength is basically the distance between 2 consecutive crests or 2 consecutive troughs. That is actually known as your wavelength. So it is basically the distance between 2 consecutive crests as well as 2 consecutive troughs. Okay, and if I want to denote this particular part, this will be lambda. and unit in that case, it is the distance definitely. So it should be in meters, but definitely we are talking about a very small part of the wave which we cannot see very easily. So in that case, definitely this particular unit can be in any term which is either nanometer or picometer or something like that. Okay, so if I talk about the origin of a wave, you can easily see by a simple experiment. Just put a stone or a marble on liquid surface, you can see the appearance of a wave pattern there. So yeah, that is the basic idea. So you are transferring the energy, but you are not transferring the matter. Okay, so this is the first part, which is the wavelength. Now the second part in that case is your wave number. This is the second part. It is nothing but the reciprocal of your wavelength. It's nothing but the reciprocal of your wavelength. So number of waves per unit length are basically known as your wave number, or it is basically the reciprocal of wavelength. Sorry, typo error. Okay, so if I talk about the wave number, which is represented by nu bar is equal to 1 upon lambda. Okay, so its unit will be in meter inverse. I hope this part is clear. Now the next part in this case, which is third portion, that is the frequency. So frequency is basically number of waves passing through a particular point in a 1 second time frame. So basically it is nothing but the number of waves passing through a particular point in 1 second is basically known as your frequency. It is denoted by nu, the stylish V, I can say. So it has a unit which is hertz, or I can say second inverse. Okay, so this is the basic idea about the moving wave. And in that case, if I talk about a particular point, so how many waves are passing through that particular point in 1 second, that is basically your frequency. Okay, in the same way, if I talk about the next term, which is amplitude. Amplitude is basically the height of the crust or depth of the trough. So that is the basic idea about the amplitude. And again, it's talking about the height. Definitely its unit will be in meter only. And last part, which is the velocity. Velocity is very easy to understand. Basically the distance traveled by a wave per unit time is actually known as your velocity. Okay, so you know that velocity will be equal to distance traveled per unit time. Okay, I hope this part is clear to everyone. This is the basic idea related to the entire portion. Now from that particular part, you know that velocity will be equal to distance travel. In terms of wave, we know that distance is basically your wavelength, and this 1 upon time per second, number of waves passing from a particular point in per second is basically your frequency. So there is a relationship, definitely there is a relationship, which is velocity will be equal to lambda multiplied by your frequency. Definitely we are going to more elaborately discuss about this particular part, because if I am talking about the light, this velocity becomes a very specific unit, which is 3 multiplied by 10 raised to the power 8 meter per second, which is denoted by C. So we know there is a equation that is nu is equal to C upon lambda. So this is the origin of this same equation. I hope the entire portion is clear to everyone. And last part, I am just introducing here the concept of electromagnetic radiation, because in the next class we are going to discuss about the entire portion related to wave nature. Then we are going to discuss a very important concept, that is the basic idea of a particle nature also, which corresponds to 2 important terms. First one is your black body radiation, and next one is your photoelectric effect. Both are very important. Okay, so basically if I talk about the electromagnetic radiation, definitely the radiations, we are talking about the waves only. Now the basic thing in that case is that waves which has both electrical as well as magnetic field, because you can see the name electromagnetic. It means it consists of electric field as well as it consists of magnetic field. If a particular type of radiation consists of both the fields, that radiation is actually known as electromagnetic radiation. Now, what is the direction of these fields? always remember that electric field and magnetic field, they are perpendicular to each other and perpendicular to the direction of propagation. Direction of propagation means the direction in which wave is propagating. So you know this left hand and right hand thumb rule, hand rule from your 10th class, I know. So let's say this is the first finger is the direction of propagation. This is the wave which is traveling. Now this second finger is the direction of your electric field, and this thumb direction is basically direction of magnetic field. So they are perpendicular to each other and they are perpendicular to the direction of propagation. So this is the direction of propagation. Let's say this part is your electric field and this part is your magnetic field. So always remember, this is the basic idea about the electromagnetic radiation. I hope up to that part everything is clear to everyone. Okay. Now if I talk about the basics of this electromagnetic radiation, always remember they do not require any medium, because you know that sunlight actually travels from outer space to our earth. In earth we have atmosphere, but in the outer atmosphere there is no mode. There is no mode of any type of travel. So in that case, always remember electromagnetic radiation travels with the speed of light, which is basically c 3 multiplied by 10 raised to the power 8 meter per second, and do not require any medium for their propagation. Very important point. Okay, that's why they are highly specific. And when I'm referring to this particular part, definitely I'm considering light. Definitely I'm considering light, or I can say sunlight. Okay, because we have the first source, so definitely we are going to discuss more elaborately about this sunlight. Okay, there can be many type of electromagnetic radiations definitely, which can differ from each other in terms of their wavelength as well as frequency, and that's why it is actually very much required to understand about the nature of these characteristics, so that we can differentiate different type of components. So basically in sunlight also you can see we have a visible region, we have a UV region, we have IR region. You can see like it consists of different type of components. So this is the basic idea about the entire portion. Now if I talk about the basic classification, you can see all the classifications very easily, although we have more classifications also, but now we are more concerned about the radio wave. Then we have microwave, infrared, visible, UV, X-rays, gamma rays. We have also cosmic rays also, but yeah, we are more concerned about this part only. In physics, definitely you are going to learn about much more about these electromagnetic radiations, cosmic rays also you are going to discuss. But yeah, in chemistry, we are more focused on these rays, which are basically your electromagnetic radiations. So we have radio wave, we have microwave, infrared wave, visible wave or visible light, ultraviolet rays, X-rays, gamma rays, and you can see their wavelength as well as frequency range is actually entirely different. So this is the basic idea about all the electromagnetic radiations. In next lecture, we are going to discuss, or we are going to start with the electromagnetic radiations itself. We are going to solve certain questions related to this particular part. Then we are going to move to the next part, which is Planck's quantum theory and your particle nature. Okay, I hope everyone enjoyed today's session. I hope they learned something new related to the entire part of structure of atom. I know like this was more of a theoretical session, and again let me clarify one thing. This is a very basic session. This lecture is a very basic lecture. If you are preparing for JEE mains or advanced, even if you are preparing for NEET examination or if you are preparing for any other examination, this lecture is going to remain as it is, because it's a very basic lecture. It's the introduction part of structure of atom, and in the next portion, upcoming portions, you will get to know about more concepts related to the structure of atom, and definitely we are going to practice more and more number of questions, because I know your main concern is, sir, how to practice more questions, how to deal with the questions. So this chapter is a very good example. We can solve enormous questions, and we will try to solve n number of questions related to this particular chapter. Okay, so that's all from my side. Thank you so much.